we are going to discuss types of addresses. Then first type of address is MAC address, and second one is IP address.
IP address.
First we will discuss about MAC address.
Important.
Yes. First, so topic is MAC address first. MAC address. So it is an 48 bits address. 48 bits address and represented in hexadecimal. Do you all know about hexadecimal?
Yes.
Hexadecimal. So can anyone tell me how many bits is required to represent one hexadecimal character?
255.
No. That's not right answer.
16.
No. How many? See, understand my question first. Whenever interviewer or anyone is asking question, first of all, within your capacity, you should understand question. What is the exact question? First understand question and then try to answer. So my question is, how many
I think
bits?
8. 8.
8? No.
What's the question?
Question is, how many bits is required? See, MAC address is 48 bits address and represented in hexadecimal. So how many bits is required to represent one hexadecimal character so that we can find the total number of character in MAC address? Getting my point? See, in hexadecimal, there are how many character? There are 15 character. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, sorry, not 10, it's A in the hexadecimal.
Okay.
Right? After that, B, C, D, E, and F. These are 15 character of hexadecimal. So to represent 0, you need, to represent one hexadecimal character, you need only 4 bits. Like if I will talk about the 0, so what will be the binary of 0? 0, 0, 0, 0. This is binary. Binary, and this one is hexadecimal character. If I will talk about the binary of 1 in hexadecimal, this is hexadecimal character. So binary of 1 will be 0, 0, 0, 1. Getting my point?
Yes.
If I will talk about the 2, so hexadecimal, this is hexadecimal character. So binary will be what? 0, 0, 1, 0.
Okay.
This is binary of 2.
Now I got you.
After that, binary of 3. 0, 0, 1, 1. Am I right?
Yes.
Binary of 4. Binary of 4. 0, 1, 0, 0. Binary of 5.
1, 0, 0, 0.
No. 0, 1. See, this is a 4. This one is 8. Yes or no? So 4, 0, 1,
yes.
5.
Yes.
Right? After that, binary of 6. 0,
2, 4, 0,
4.
1, 1.
Yes, 0.
0. Yes.
This one is 4 and this one is 2. So total
Gotcha.
6.
Gotcha.
After that, binary of 7.
0, 1, 1, 1.
0, 1, 1, 1. Binary of 7.
1, 0, 0, 0.
How we know like this? 0, 1, 1, 1 something.
Yeah, we know that.
Okay, let
Just
me make you understand that also.
Okay.
See, this is binary of 8. If I will talk about the binary of 9 in hexadecimal character of 9, and binary will be 8001. This is
One.
9.
Mhm.
If I will talk about the 10, so 10 is not there in hexadecimal, it's A. Instead of 10, we are saying A. A means it is 10. So binary will be 8, 0, 1 and 0.
Zero.
Yes or no? If I will
Yes.
talk about the B, so it will be
11.
11 means 8, 0 to 10 and 1, 11. Yes.
Yes.
Binary of C. C means 12. So 8, 0 and 8 plus 4, 12. This will be the binary of C. If I will talk about the binary of D, D means 13. So 8 plus 4 plus 0 plus 1. After that, if I will talk about the E, 1, 1, 1, 0. Yes. And if I will talk about the F, last one, so see, this one will be all 1. So you need a 4 bits. You know, if all 4 bits is 0, that means hexadecimal character is 0. If all bits is 1, that means hexadecimal character is F. Getting my point?
Yes.
Okay.
And see, the formula is very simple. You will start from here, 2 to the power 0. So tell me, brother, 2 to the power 0 will be 1, and 2 to the
Yes.
power 1 will be what? 2. 2 to the power 2 will be what? 4. 2
Four.
to the power 3 will be what? 8. So this one is your 4 character. After that, 16, 32, 32, after that 64, after that 128. This is 8 bits. This one is 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. But we need only 4 bits to represent hexadecimal character. Only these 4 bits. Yes or no? Because my minimum value in hexadecimal is 0 and maximum value is F. Getting my point, guys?
Yes.
Yes.
Is it clear to everyone? Or still
Yes.
anyone have problem? This one is
No,
8 bits. We will use 8 bits in IP address because we represent IP address in the decimal. Okay. So if all 8 bit is 0, that means decimal value you will get 0. If all 4 bits is 0, that means you are getting value 0, and that will be your hexadecimal value. Getting my point? So okay, if MAC address is an 48 bits address, now you tell me, if there is one address whose size is 48 bits and represented in hexadecimal, and to represent one character in hexadecimal we need 4 bits. So how many total character will be there in the MAC address? 48 divided by 4.
4.
Yes or no? So it will be what?
Yes.
It will be 12.
12.
That means, yes,
Yes.
is it clear,
Yes.
everyone?
No, can you explain one more time,
Yes,
please?
yes. Why not? I can explain 1000 times.
Thank you.
Just you need to tell. Okay. See, I am seeing an address whose size is 48 bits. Done?
Mhm.
Okay.
Yes.
And we represent this address in hexadecimal. And as you know, to represent one hexadecimal character, we need 4 bits.
4 bits.
Right? That means how many total character are there in the MAC address?
48.
48 bits. But we represent it into hexadecimal. And to represent one hexadecimal, we need 4 bits. So there are 12 characters. See, if I have an address like 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. How many characters are there? Total 12 characters.
15.
15 characters are there. Yes or no?
Yes.
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 Total. And each character carry how many bits?
4.
4 bits. So what is the total size of this address? Total size of
It's
this
15
address
times-
is
15 times 4.
15 multiplied by 4 bits. Yes or no?
Yes.
Yes.
In the same way, if we have an address of 48 bits which represented in hexadecimal, so how many bits is required? You will divide it. You will divide 48 by 4. Yes or no? Let's
Yes.
say if we have an address with where we have only 12 character, 1, 2, 3, 4, 5, 6, 7, 8, it is 9, and let's say 0, 10, 1, 2, 11, 12. So there are 12 character. Yes or no?
Yes.
Each character carry 4 bits. Yes or no? That means it is an 48 bits address. Am I right?
Yes.
Now is it clear?
Yes.
Yes.
I got it.
Right? Okay, so in the MAC address we have total 12 character. It's clear. Yes or no?
Yes.
We have 12 character in a MAC address. Now this 12
Oh,
character,
in
let
MAC
me
address we have
write. Yes.
In the MAC address, we have 12 character.
Yes, 12 character. And total size is 48 bits. And as you know, to represent one hexadecimal character, we need 4 bits.
Could you say one example of MAC address?
Yeah. I am giving you example. But first of all, see, these are 12 character and these are 12 hexadecimal character. That means multiply by 4 if you calculate it into bits. So it is an 48 bits address. Now see, I am writing one MAC address. Let's say here 1 A B C D 1 8 7 anything 2 4 6
11.
2 11 and let's say one
Yes.
more. This is one MAC address. This is one MAC address. Now, representation of this MAC address can be different. You know, you can represent this MAC address like A, 1A, iPhone, BC, iPhone, BC, iPhone, CD, iPhone, 18, iPhone, 75.
Is
I-
hyphen represent the character?
No. See, this is just a representation. Just wait for 2 minutes. 75 hyphen 69 hyphen 1. Hyphen is nothing. This is MAC address. I am a manufacturer company whose representation is different. Let's say I want to represent it like 1A colon BC colon CD colon 18 colon 75 colon 69 colon, and in last, how it's possible that there are only 11 characters? That means
It's 13.
2 4 6 8 10 12. So here I have missed one character.
Right here, in the bottom, both of them are 14 character.
No, you put
Okay.
C 2 times, twice.
Okay, I have put C 2 times. So this will be like this. Here will be iPhone. This is the actual representation of this MAC address. Like I want to represent say MAC address with colon, so I can represent it 1A colon BC colon D1 colon 87 colon 56 colon 91. Okay, someone, let's say Cisco want to represent this address like 1A BC colon D187 colon 5691. Okay, do you think that there is any difference in these three MAC addresses? No, guys, these all MAC addresses are same. These all MAC addresses are same, just differences of representation, and different vendor company have their own representation of MAC address. Let's say if I want to show you the MAC address of my computer, CMD, and config all IP config all. So see, my MAC address is this one. So this is window representation. Where is MAC address? Here it is. This one is window representation. Window represent MAC address like this. If I will talk about the Cisco representation, so let me take you on packet tracer.
Yeah, it means like MAC address is always 12 characters.
Yes, MAC address will be always of 12 character, and representation can be anything. Like if I will take one router over here, let me take one router and one switch as well, and I am connecting it. And on fast Ethernet 0/0, I am going to configure one IP address, and then I will show you the MAC address of that interface. Or directly I can show you. So interface F0/0. You can see the MAC address. So this is Cisco representation, but total character is same, 12. In Windows also, in Cisco also, in Linux maybe representation will be different, but character will be same. Getting my point?
Clear, yes.
So this is MAC address of Cisco. So Cisco represent MAC address in 3 field. Done?
Yes.
Yes.
Window represent MAC address in 6 field. Yes or no?
Yes,
But
clear.
both MAC addresses are same. Now see how vendor company is, assigning MAC address to computer. For that, let's say I am taking example of 2 company. There is one company whose name is Dell. You all are familiar with Dell?
Yes.
Yes.
Dell and HP?
Yes.
Yes.
HP. So both companies are, manufacturing computers, laptop, yes or no?
Yes.
Yes.
Okay. So how it is possible that MAC address of Dell computer and HP computer will different? How HP will came to know that this MAC address is already used by Dell, I cannot use this MAC address? For that, see, we have divided MAC address into 2 part. We have divided MAC address into 2 part. First one is OUI. OUI. OUI stands for Organizational Unique Identifier, and second one is vendor assign. Okay, means vendor will assign only this part. OUI is 24 bits. First 24 bits, and vendor assign is last 24 bits. 4 bits. Okay. Now, if Dell want to manufacture their computer, they have to purchase OUI first from the INA. So let's say Dell have purchased one OUI. OUI of Dell is, let's say what? 0, 0, 0, 0, colon, 0, 1. This is how many bits?
24.
24 bits.
Yes.
This 24 bits is of OUI. In the same way, HP also need to purchase one OUI. Let's say HP purchase one OUI, that is 0, 0, 0, 0, colon, 0, 2. Done. Now through one OUI, Dell can manufacture how many computer? See, what will be the MAC address of first computer of Dell? It will be
00001000002.
wow. 0 0 colon 0 0 0 1. This is first MAC address of Dell. Yes or no? Second MAC address of Dell will be what? 0 0 colon 0 0 0
002.
2. Fourth MAC address will be 0 0 colon 0 0 0 3. What will be the last MAC address of Dell computer? FF colon FFFF. Yes or no? Till here Dell can manufacture computer through one OUI. Getting my point, guys?
Yes.
In the same way, HP, what will be the first MAC address of HP? 0 0 colon 0 0 0 1 0 0 colon 0 0 0 2, and last MAC address of HP will be also FF colon all F. Yes. See, even vendor assigned part of Dell and HP is same, but MAC address of both is different. Yes or no?
Yes.
Yes.
Because of OUI. So this is how our MAC address is globally unique. Who is responsible for it? The company, the organization whose name is INA. Internet Assigned Number Authority. Done. So this is all about the MAC address. MAC address, now it's very clear that it is an 48 bits address. We have total 12 character in it, and we represent MAC address in the hexadecimal. That's why we have 12 character. And there are two parts in MAC address. First one is OUI, second one is vendor assign. Every vendor company need to purchase OUI from the organization whose name is INA, and they have to assign 24 bits by their self. And this is how my MAC address is globally unique. Like if I will talk about the MAC address of this computer, so see, 2, 4 and 6. These are part of OUI and these are part of vendor assign. If I will talk about the Cisco, these are part of OUI and these are part of vendor assign. Getting my point?
Yes, got it.
Done. Is it clear to everyone, or any doubt, guys?
Yes.
Any doubt to anybody? No? So total size of MAC address is 48 bits. How many characters are there? 12 characters, and we represent it into hexadecimal. Representation of each vendor can be different. Done?
Yes.
Now let me move to IP address. That is second type of address. IP address. Guys, IP address is an 32 bits address. It is an bits address, and we represent it into decimal. Represented in decimal. Okay, if we have an address of 32 bits, means let's say I am denoting bits by X. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 32. How many bits are there?
Should be 32.
32 bits are there. And this x
Yes,
can be
yes, yes.
x can be what? You know, we represent IP address into decimal, but it is a 32 bits address. You know, bits can be 0 or 1.
0 or 1.
It can be 0 or it can
Or
be
1.
1. Yes or no?
Yes.
Yes.
And we have 4 field in IPv4 address. We have, you know, here in IPv4 address representation is fixed for all vendor company. Done? Here representation is fixed for all vendor company. We divide IPv4 address into 4 part. First 2, 3, 4, 5, 6, 7, 8. This one is one part. 1, 2, 3, 4, 5, 6, 7, 8. This one is second part. 1, 2, 3, 4, 5, 6, 7, 8. This one is third part and this one is fourth part. Getting my point? There are 4
Yes.
field in IPv4 address, and this is fixed for all organization. Here we don't have, you know, representation depends on the organization, where representation is fixed. Okay, and we separate all field with dot here. That is also fixed. We separate all field with dot. Okay. So each field carry how many bits? Each field carry how
8.
many bits?
8.
8 bits. Yes. So let's say I am writing one, you know, by IP address in binary. Let's say 0,
Yes.
1, 0, 1, 0, 1, 0, 1. Dot 0, 0, 0, 1, 0, 2, 4, 6, 8, 1, 0. Dot 0, 0, 0, 1, 0, 0, 1. And 0, 0, 0, 0, 1, 0, 0. Okay. Now tell me what will be the decimal value of this binary?
64 plus 16
Please
plus
calculate
4
it.
plus 1. Oh, calculated.
Please calculate it, guys, everyone. What will be the complete decimal value? This dot, this dot, this dot, this, like that. Please calculate it.
85 for the first part. $85, 10,
Actually, I don't know.
85, 10, 9, 4.
9.
4.
Yeah. Here what value you will get? At the first,
80,
in the first
it
field?
was 85.
No.
Hold on. 65.
60.
Plus
This one is what?
16.
64. This one is what?
64.
16.
16.
This one is 8. And this one is 1.
That one is 4.
So total what value you will
No,
get?
that one is 4.
This
the-
one is 4 and this one is
Yes.
1.
Yes, not 8, 4.
Yeah, 4. Sorry. So what value will you will get over here? 85.
Yes.
85 dot
9.
10,
10.
Oh, yeah. 10.
9,
9.
4.
4. Very good. This is a IP address. And this one is a valid IP address. Okay. Guys, now question is, I am writing one IP address over here, that is 10.256.1.1. Is it a valid IP address?
No,
Why?
because 256 is
Because by using 8
larger
bits,
than
you cannot write
255.
this value.
255
You
is
have
maximum.
only 8 bits, yes. By using 8 bits, you can write maximum value what? 255. See, or if all 8 bits is 00, all bits is 0, then decimal value will be what? 0. If all bits is 1,
255.
then you will get value what? 255. So in
Yes.
one octet, value can be 0 to 255 only, yes or no? So your lowest IP address can be 0.0.0.0 and your largest IP address can be 255.255.255.255. Yes or no?
Yes.
Yes.
Like your MAC address, if I will talk about the lowest MAC address, so lowest MAC address can be what? 12 times 0,
Yes.
and largest MAC address will be what? 12 times F.
F. Yes. Yes.
Yes or no?
Yes.
So a IP address can be belong from 0.0.0.0 to 255.255.255. This is interview question and CCNA exam question as well. In one CCNA 20030 exam question, Cisco have this written one wrong IP address like this, and they were asking that it is an valid IP address or not. And they can ask you the reason as well, that why this IP address is invalid. Okay, so make sure you have knowledge that in each field value can be 0 to 255 only. Okay,
Okay.
now see, we have some classes in IPv4 address. We have some classes in IPv4 address because we have only 32 bits address, yes or no?
Yes.
And we have lots of people in the world who need IP address. So is it possible to provide one IP address to everyone?
No.
Not possible. And lots of people are using multiple IP address. Like nowadays, if you are using a smart TV, so your TV also need one IP address. Your car remote also need one IP address. Yes or no?
Yes.
Yes.
So at the initial time, just if I will talk about the 6 to 7 year or 10-year back, it was a challenge, right? How to reduce the shortage of IP address, how to reduce the shortage of IPv4 address. Yes or no? You are already familiar with this, that yes, we have shortage of IPv4 address because
Yes.
we have only 32 bits address. That means total number of IP address that we can design is 4.2 billion, 2 to the power 32. Yes or no? Total
Yes.
IP address that we can design is 2 power 32 only. Okay, so to reduce the shortage of IP address, we divide IP addresses into classes. Okay, into some classes: class A, class B,
C, D,
we
E.
have class C, then class D, and class
E.
E. Very. As a network engineer, you will work on class A to class C only. Class D is reserved for multicasting. This one is reserved for multicasting. Multicasting means, like we have routing protocols like OSPF, EIGRP. You guys are familiar with this routing protocol?
Can you repeat it?
Like we have routing protocol like EIGRP,
Yes.
OSPF, and these routing protocols need one multicast address. These protocols work on multicast address. In upcoming day we will understand that also. So this range is, this class is reserved for multicasting. So whenever anyone need multicast address, they can reserve from this class. Let's say OSPF have reserved one IP address for sending their update message or hello message. EIGRP have reserved one IP address from this class. All the technology and protocols which need multicast address, they have reserved it from this class. After that, if I will talk about next class, that is class E. So class E is used for research. Research like in ISRO, NASA, in this research center they are using IP addresses from class E. Now as a network engineer we are working on these three class A, class B, class C. And if I will talk about the classes, so we divide IP address into classes on the value present in first octet. Value present in first octet only. Like, see, here we have 4 fields in the IP address. Yes or no?
Yes.
In each field there are 8 bits. So we called one field to octet. This one is first octet. This is second octet. This one is third octet. We called it octet. One field to octet because there are 8 fields. Getting my point?
Yes.
So value present in first octet means in this field. Right, on the basis of that we divide IP address into classes. So if I will talk about the range of class A, so range of class A is 0 to 127. If value in first octet belongs to 0 to 127, that means that IP address belongs to class A.
Class A.
If I will talk about the class B, so range of class B is 128 to 191. If I will talk about the class C, so range of class C is 192 to 223. So if I am writing one IP address over here 10.255.255.255, this IP address belongs to which class?
Class A.
Yes, you will check only the value in first octet. The value present in first octet is what? So if value is 10, okay, 10 is in between 0 to 255, that means it belongs to class A. If I am writing one IP address 172.168.10.01, this
B.
IP address belongs to which class?
Class
Class
B.
B.
Class B. Because value in first octet is 172. 172 is between 128 and 191. If I am writing one IP 192.168.10.10, so this IP address belongs to which class? Class C.
Yes.
Because here value is 192. Now question is how we divide IP addresses into range. This is also a question. For that, guys, you have to understand the subnet mask. Okay. First, try to understand one thing. Any IP address, like I am writing one IP 10.10.10.10. This is a valid IP address. Everyone know.
Yes.
But this IP address is combination of two things. Each and every IP addresses are combination of two things. First is network bits. And second one is host bits. Network bits plus host bits. Now how to identify how many network bits are there and how many host bits are there in an IP address?
Depend on class, right? For
Yeah.
class.
Depend on subnet mask.
Depends on subnet mask. So we have a tool, or you can say you have a marker which specify how many network bits are there and how many host bits are there in a particular IP address. And subnet mask is also predefined for each classes. Subnet mask is predefined for each classes. If I will talk about the subnet mask of class A, so can anyone tell me what is the subnet mask of class A?
Yeah, it's a 255.
First of all, range is 0 to 127. And subnet mask is
255.
255.2.
250.
Yes.
255.0.
255.0.0.0 means in class A there will be 8 network bits. Means 1 represent network bits and 0 represent host bit. So 255 means in first octet all bits is what? 1. Yes or no?
Yes.
In the subnet mask. Okay. For class B,
255.
00.
range is, first of all tell me the range.
128 to
191.
190 to
Okay.
191.
and subnet mask is 255.255.0.0. So
I
here
think
how
it was
many?
191.
Sorry, 191. Definitely. So here, tell me how many network bits is there?
Two.
Not two.
255. I mean, yeah.
Here we have 8 bits and
8
here
bits,
we
yeah.
have 8
16.
bits. Means total
16.
16 network bits in
Yeah.
class B. This is class B, not N. Sometime I am, my writing skill is very bad.
That's okay. No worries.
Class C range is
192
192 to
223.
223 and subnet mask is 255.255.255.0.
0.
Means in class A there are 8 network bits. In class B by default, I am talking about the by default behavior. By default in class B there are 16 network bits and in class C by default 24 network bits.
Yeah.
Okay, now you tell me what is the host bits in class A?
24.
24.
Host bit is
24.
definitely 24 because total size of IP address is 32. Out of 32 bits, 8 bits are network bits. Then definitely 24 bits are host bit for class B.
16. 16.
16
Yes.
definitely for class C.
8.
Definitely 8 bits. Okay. Now to understand how we divide IP address into classes, you have to understand that, see, in the first octet we have reserved one bit for class A, 2 bit for class C and 3 bit for class C. See, in first octet there are 8 bit. If I have reserved first bit, that will be always 0. Okay, I have reserved 1 bit and this bit will be always 0 for class A. So now how many free bits are there in first octet? 7.
Yes.
So if 7 bits is what? 0, 4, 5, 6, 7. Then what value you will get? And if 7 bits is 1, then what value you will get?
0.
Here, what value you will
254.
get?
That's 0.
0. Here, what value you will get?
254.
1.
127.
1.
You can calculate it.
Oh, you.
This is what?
Go
64,
on the right. Okay.
right? So this is range for which class?
A.
Class A. In the same way for class B, we have reserved 2 bits. First bit will be always 1 and second bit will be always 0. Okay. Now how many free bits are there? 6.
6.
Because out of 8 bits we have reserved 2 bits. So there are free 6 bit. So if all bits is 0 and if all bits is
1.
1, then what value you will get over here? Tell me.
To 0 to 1.
Here you will get what value? This is 128. So your range will start from 128. Yes or no?
Yes.
Getting my point?
Yeah. No, I get it.
First bit is 1. So here you will get value
Yeah.
128.
Yeah, I got it,
Here you will get value what? 128 plus 32 plus
255
16.
minus 64.
So you will get actually 191 over here. You can calculate.
Yeah.
Right? In the same way for class C, we have reserved 3 bits. Okay. Now anyone after this training will go for CCNA exam or not?
Yep.
Yes.
Okay, so I am asking you question of CCNA 200301 now. So here we have reserved 3 bits. So how many free bits are there? 5. So if 5 bits is 0 and if 5 bits is 1. So tell me what will be the minimum value and what will be the maximum value over here.
192
Two,
to
Yeah, here
223.
you will get 192. Here you will get
223.
223. Now question is very simple. From class A, how many network we can design? 2 to the power 8, 2 to the power 7, 2 to the power 16 or 2 to the power 24. What is the right option? Option A, option B, option C, option D. How many network we can design from class A?
2 to the power 8.
You know, most of the people are saying 2 to the power 8, but this one is wrong answer. Brother, you have already reserved 1 bit over here. You have only free 7 bits.
Oh.
So how you can? Yes, right answer of this question is actually 2 to the power 7. In the same way for class B, most of the people are saying we can design 2 to the power 16 network, but you can design 2 to the power 14 network only. Yes or no?
Yes.
Yes.
For the class C, how many network we can design? 2 to the power what? 24 or 21?
21. You get 3.
21.
Pair of
24
networks.
minus 24 minus
21.
3. It's gonna be 21.
Exactly. We have 24 bits for network, but we have reserved 3 bit for class C. Done?
Yes.
Now this was the just overview of IP address. We are going to understand now subnetting. So why we come up with subnetting? Only for one reason to reduce the shortage of IPv4 address. We divide IP addresses into class. After that, in classes again we have private IP address and public IP address from each class. From class A, from class B, class C, we have a range of private IP address and public IP address. Private IP address is, let's say, 10.0.0.02, 10.255.255.255.255. This is reserved for private. All other IP address are reserved for public. So that are routable on internet, and this IP address is not routable on internet. This one is your private network. Getting my point?
Yes.
First, we divide IPv4 address into classes, and then in each classes we divide IP address into private and public. Then again we come with subnetting. Again, problem is not solved with subnetting, so we come up with NAT, PAT. Those are, if you will learn those things in very carefully, then you will understand actually we are using NAT only to reduce the shortage of IPv4 address. That is the reason of NAT. Okay, so now next topic is subnetting. We have time now?
Yes.
Yes.
Subnetting. So question is, first of all, what is subnetting? If anyone have any knowledge?
Yeah. Like if you have a network and we want to make more networks from one network ID, we can create more networks. That's what we call subnets or subnetworks. For example, like we have one IP address, right?
Okay.
And we just divide this IP address to more networks. It called like subnetting. Like we create more networks from one IP.
Subnetting. I think subnetting is analyze IP address, find the last IP address, first IP address, and some more information. Just I forgot.
Somehow he was right.
Uh,
But what I am saying, Subnetting is a process which is used to divide large network into a smaller network.
Small.
Let's say I am taking one example. 192.168.10.0 and subnet mask of this network will be what? Okay, first of all tell me this IP address belongs to which class?
Class B.
Class B.
Class C or class B?
Class C.
So
Class
what
C.
is subnet mask? Default subnet mask 255.255.255.0.
0.
These are what? Network part and this is what? Host part,
Hotspot.
right?
Yes.
Okay, this is network ID, this one is the subnet mask. Can you tell me what will be the first IP address of this network?
192.168.10.1.
One.
1. Yes.
What will be the last IP address of this network?
192.
168.10.254.
255. Yes or no?
Yes.
You have no touch first 3 octet. Why?
Because it's
Because
class
subnet
C.
mask told you to not touch these 3 octet. These are network portion.
Network. Yeah, we cannot change it.
Now question is how many valid hosts are there? 255.
Fine.
There are total 255 IP address. Okay.
Yes.
Yes or no?
Yes.
Yes.
Total number of IP address is 255 in this network. Now some organization need to design one network like this. A switch, they have one switch, they have some computer, there are, let's say, how many computer? 50 computer. 50 computers in their network. Yes,
Yes.
all computers are connected through switch. And let's say this switch is connected with one router and this router is connected with internet. Don't worry about the connectivity, we will understand it in very details in upcoming days. R1, this one is my router, this one is my switch. So this organization need how many IP address? There are 50 computer and one IP address required for router interface. Yes or
Yes.
no?
Yes.
So total number of IP address that this organization need is what? 51. Yes or no?
Yes.
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 So how they can get 51 IP address? So they will use IP address from which class? From class C?
I think class A.
No, class A. It will be very large IP address
Yeah.
in
Okay,
class
class
A.
C. Yeah, class C.
Class C.
Yeah.
So in class C, he will get how many IP address? 255. It will use how many IP address?
50.
50 only? 51 let's say. So we have wasted how many IP address?
200. 299.
200. 204.
204.
204. Yes. They have wasted how many IP address? 204. In future, let's say this organization need to add one more network over here, one more department over here. Let's say this time he is adding one more switch over here and few more computer over here. Let's say again they are adding 50 computer, right? They have connected all computer together through switch and they have connected switch to their router. Now can this organization use REST IP address in this network?
Yes.
No. Without subnetting, it cannot use.
Okay.
Without subnetting, he have to use different network, 192.168. Let's say 11.0 network. They have to change the network portion. Again, he will waste lots of IP address. So to
Yes.
reduce this wastage, actually what we are doing, we are dividing large size of, we need to divide large size of network into a smaller part of network. Yes or no?
Yes.
This is subnetting. Through subnetting, what this organization can do, this organization can divide this main network into two part. They can divide. So you will understand the dividing process. Okay. But before that, let me make you understand one thing. That is, let's say I have one IP address 192.168.10. Or not 10, 10.10.10.10. What is the network ID of this IP address, guys? Network ID means, you know, main family member.
No.
Network ID. This IP address belongs to which network?
A network.
Network
Class,
ID will be what?
class A.
10.0.0.0.
000.
This is network ID.
Mm-hmm.
And this one is host IP address. Getting my point? Now question is how you are calculating the network ID from the IP address. Actual way to calculate network ID from the IP address is 10.10.10.10 is your IP address. First of all, you need to find the subnet mask. Subnet mask is what? 255.255.255.0. Now we need to convert your IP address and your subnet mask into binary.
Mm-hmm.
So can you tell me what will be the binary of
10,
your
10, 10.
network? 00001010.
1,
Yes or no?
Yes.
After that, 00001010. Then 0001010. And then 0001010. After that, you will convert your subnet mask into binary. So subnet mask will be
1111.
1, 1, 1.
then
111.
1, 1, 1.
2, 4,
One more.
one more. Then
1111. And
And
Then-
then 000.
0. And then,
but this is not subnet mask of class A. Yes or no?
yes.
Subnet mask of class is 255.0.0.0. Let's say this is my subnet mask.
Okay.
And here you will perform what?
Subtraction.
AND operation. You know AND operation?
Yes.
In AND operation, if input is 0, 0, then output will be what?
0.
0.
0.
If input is 0, 1, then output is 0. If input is
1, 1.
1, 1,
1. Output is 1.
1, 1, then output will be
1.
1. In only one case, output will be 1, right?
Yes.
So after performing AND operation, guys, what value you will get over here?
We could
1,
0, 1 will be what? 0,
0.
0, 0, 0, 1, 0.
yes, only we will have
1,
the
0.
change in the last octet.
Yes. So this will be the result. Here also 0, 0, 0, 1, 0, 1, 0, dot 0, 0, 0, 1, 0, 1, 0.
Mm-hmm.
And then all will be what?
0.
0.
0 over here. Yes or no?
Yes.
Yes.
Now you need to convert it into decimal again. Convert it into decimal. So decimal, again you will convert it into decimal, then value you will get what? 10 over here, 10 over
10,
here, 10
0.
over here, 0 over here. So this is what? Your binary. Sorry, this is your network ID. Getting my point how we are calculating network?
Yes.
Now you tell me, if I have one IP address 192.168.10.0 and if subnet mask is 255.255.255.128, here IP address is not this one, let's say 130. Can you tell me what will be the network ID?
Yeah, we're gonna.
Can anyone tell me what will be the network ID?
192.168.10.1.
10.1?
No.
No, no, no.
128 is 10.0.
10.0.
Not 10.0.
Hold on.
128.
That's 128.
Okay, we're gonna
See,
divide. Yeah.
first of all, see here all bits is 1. Here also all bits is 1. That means these value will be same, yes or
120.
no?
Yeah.
So I am
127.
going to convert 130 into binary. So what will be the binary of 130?
127.
1,
Binary.
1, 0, 0,
1.
0, 0, 0, 2, 1, 0.
This one will be the binary.
Yes.
2, 4, 6, 8 exactly. And what will be the binary of 128?
1, 0, 0, 0, 0, 0.
Here if you will perform the AND operation, what value you will get? 1, 1,
1,
1.
1.
yes.
And all rest will be what? 0.
0.
What decimal value you will get?
120.
120.
128. That means your network ID is what? 192.168.10.128.
Mm-hmm.
Getting my point?
Yes.
Okay. Now again I am going to give you one network 192.168.10.165 and subnet mask is 255.255.255.248. Now can you tell me 248? Can you tell me what will be the network ID? See, you don't
What?
need to do anything with first 3 octet.
Okay, 192.168.10.248.
Yeah.
Is that right?
No.
No?
Just give me 1 minute.
It should be
Yeah, we have to
192.168.10.163.
convert it to. Hold on.
192.168.10.1.
163.
No, 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 no.
Yo. Okay. 1001. Give me 1 second. It should be 10.
No, 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 no.
Hold on again. Hold on.
148. No, not 10.
should I do?
32.
First converted to binary.
First convert binary, yes, to 165 and
It's gonna be
258,
1.
248, and do AND operation. I will show you the shortcut method as well to calculate the network ID. But first, this is the actual way. This is the behind scene. So that's why I'm asking you this question. Subnetting is important topic of CCNA.
Okay. 1, 0, 0. Yeah. I think it should like 0.
No, no, no. It will
No?
be not 0. See, I am
No,
doing it,
no.
okay?
Okay.
Binary of 165 will be what?
160. Hold on.
165 binary.
No, it's binary 101000101.
Oh, 165.
10
Yeah, 10,
00
10, 0101. This is binary of 165.
Yeah.
After that, binary of 248. Binary of 248 will be what?
1.
1,
Give me a sec.
1.
Yeah, 1. 1. I think.
This will be the binary of
Yeah.
248. Now here, if you will perform AND operation, what value you will get? 1 1 1 1 0 0 1 1 1 0 1 0 0 1 0
It's gonna be
1 0
160.
0. All will be 0.
160, I think.
This one is what? 128 plus 32.
160.
160, 128 plus 32. Yes or no?
Yes.
What value you will get over here?
192.168.10.160. I said 160.
You said 160.
Yeah,
Okay.
before you're starting this.
Okay. 160 is the right answer. Now, see some formula to calculate subnetting, to perform subnetting. First formula is number of network. Guys, please write down this formula in your notebook. Number of network. First thing is how to find number of network. So formula to find number of network is 2 to the power n, where n is number of network bits goes in host bit, host portion. Done. This is first formula. On the basis of 3 formula, I will make you understand the entire subnetting. But formula should be very clear with you. This is number of network. How we will find number of network? 2 to the power n. After that we will find how many network bits we have borrow from host. Done. Second formula is number of
Host,
valid host
valid host.
is equal to 2 to the power h minus
Is it
2.
just is it the same with number of available hosts?
No,
No.
this
Okay.
is different.
Okay.
Number of valid host is equal to where h is host bit. Host bits. And third formula and last formula is block size. This one is very important formula. Block size is equal to 256 minus subnet mask of last octet. Subnet mask of last octet. Okay, is all formula clear to you?
Just the example of the last one.
Block size equal to 56 minus subnet mask of last octet. Formula is clear or not? I am giving
Yes,
you
yes,
example.
yes.
Okay. Now I am writing one IP address over here, that is 192.168.10.150, let's say, and subnet mask is 255.255.255.128. Can you tell me how many bits I have borrow here? How many network bits goes in host bits? By default subnet mask, see, this
Yes.
IP address belongs to class C. That means by default subnet mask would be 255.255.255.0. But my subnet mask is different, 255.255.255.128. Yes or no?
Yes.
If you will convert it into binary, so 1. Yes or no?
Yes.
This is the binary of subnet mask. See here, means I have borrow how many bits?
One.
1 bits. 1 bits have gone from here to here, from network portion to host portion.
Yeah.
Or you can see 1 bit we have borrow. So that means here how many network will form? 2 to the power n, and n value is what? 1.
No.
N is number of network bits goes in host portion. So 1 bits is goes, right? So 2 to the power n. That means here number of network will be what? 2. Done. That means we have divided this network into 2 parts now. Earlier there was 254 hosts. Now there will be less number of hosts in one network. We have divided it. That's why here I am able to see the number of network is 2. Now if you want to find the number of valid host, so valid host formula is what? 2 to the power h minus 2. H is what? Host bit. How many host bits are there?
How many hosts?
5.
1, 2, 3,
5 or
4,
7?
7.
Oh, 7. I mean 7. Not 5.
7 minus 2. So 2 to the power 7 is? 2 to the power 7 is 128.
120.
Minus 2. It will be what? 126.
Yes.
That means this time valid host is 128 only. Okay.
126.
Yes, 126. Total number of IP address will be 128 and valid host will be 126. Now you need to find what? Network ID. So to find network ID you need to find the block size. Block size formula is what? 256 minus subnet mask of last octet. So subnet mask of last octet means last one is present in fourth octet. Yes or no? What is the subnet mask? 128. So let's subtract it. Block size is what?
128.
128. That means my first network will be 192.168.10.0 and second network will be 192.168.10.128. Getting my point?
And what will be the third one? We multiply the.
No, we have only two network.
Oh, okay.
And see the trick to find network ID. This one is my IP address 192.168.10.150. See, your block size is 128. Just you need to find the nearest number which is divisible with 128 here. What is the nearest number which is divisible by your block size? 128.
120.
So 128 is your what? Network ID.
Network
This
ID.
one is your network ID. Means this IP address belongs to this network. Okay.
Yes.
Now 192.168.10. Again 150, but this time subnet mask is 255.255.255.192. Can anyone tell me how many bits I have borrow here?
I have to convert it.
192 means here 1,
One.
and all rest bits are 0.
Two.
128 plus 64.
Yeah, 2 bits.
2
2
bits.
bits
Yes
borrowed.
or no?
Yeah.
So number of network will be what?
2.
2 to the power 2.
2 power 2 is going to be 4.
That means 4. If number of network is more, then valid host will be what? Least. Yes or no? See,
Yes.
number of valid host.
Valid host going to be 6.
2 to the power
6.
h minus 2. So 2 to the power 6 minus 2. 2 to the power 6 will be what?
4.
64.
64.
Minus 2. 64. This time you will have how many valid hosts?
62.
62, sorry. 62. Now block size will be what? 256.
256 minus
192.
192.
Yes or no?
Yes.
So what value you will get after subtraction? 4
4.
and 15
64.
minus 9 is 64. Now tell me what is the nearest divisible number to 64 to find the network ID of
64.
this first.
64.
64 and 64 plus 64 is 128.
Yes.
128 is nearest number, na? Or see,
64. 64 is not the nearest number.
64 plus 64.
It should be.
See, if you
it,
will
it should be
divide
larger.
150
It should be larger than the number. It can
150
be the
divided
same.
by 64. What value you will get over here? You will divide it by 2. So 128 you will get 30 rest. So you need to 30, not 30.
Okay.
128, the 150 minus 128.
So I'm confused here. Yeah.
Just wait.
Okay.
Just wait. See, okay. First of all, how many network we have? 4. And block size will tell me the next network ID. First network ID is 192.168.10.10. 10.0. My first network will start always from 10.0. Second network will be 192.168.10. Block size 64. You will add block size over here. Third network is 192.168.10.64 plus 64 128, and fourth network will be what? 192.168.10.150.
192.
192. And fourth network will be what? Fifth network 256. So that is not valid. Yes or
It's not
no?
valid. Yes, it's
So
256.
we have only 4 network. Okay, this network will end on which IP address? 192.168.10. See, if next network is starting from 64, that means this network is ending on 63. Yes or no?
Yes.
Okay, this network, what will be the last IP address? So next network is starting from 128. That means this network will end on 192.168.10.127. Yes or no?
Yes.
What will be the last IP address of this network? 192.168.120. Sorry, next network is starting from 192. So this network is ending on
191.
191. Next network is starting from
1
256. So this network will end on
255.
192.168.10.255. Right. Okay, this one is your network ID. This is network ID. First IP address is your network ID, and last IP address is your broadcast ID. These are not usable IP address. In the same way, in each network, first network is not usable and last is not usable. Last is broadcast ID, first is network ID. Here also, here also, here also, and here also. Now, first visible usable IP address will start from 192.168.10.1. My last usable IP address will be 192.168.10.62. How many total valid IP addresses are there? 62?
60. Yeah, 60.
62? And see, here also you have calculate 62. In the same way, here first valid IP address will be 192.168.10.65, and last valid IP address will be 192.168.10.126. Here also we have 62 valid IP address. In the same way, this IP address is starting from first valid IP address 192.168.10.129 and last IP address 192.168.10.190. Here also we have 62 valid IP address. First IP address 192.168.10.193 and last valid IP address 192.168.10.254. Here also we have how many IP address? 62 IP address. Now see, my IP address was this one, 150. So you tell me this IP address belongs to which network? This network? No, this network is starting from here and ending over here. From this network? No, this network is starting from here ending over here. In this network? Yes, this network is starting, right? And if you will divide 150 with your block size, that is 64, nearest number which is divisible via 64 is 128. That is also one way to find the network ID. Yes, now you can ask your doubt.
Yeah, my question was about like almost like you solved my question, but we have like 62 hosts. This is the host bits, right?
Okay.
And my question like the black size show only next network, right?
Yes.
It's not belongs to host bits or whatever or network bits.
No. Block size will tell you only from where your next network is starting.
Okay.
Is it clear?
Yes, I understand now.
Now can I discuss another question? We have time?
Yeah, I think we have time.
Okay.
I think, guys.
Yeah.
So
Yes. Yes.
do you want to go more, or that would be enough?
So what time is it?
Yeah,
It's
12:30.
depends on you guys.
I think we have to do a little bit of practice.
We have
Tell
class
me, I
tomorrow,
don't have
right?
any problem.
Yeah, we have class tomorrow until
Okay.
Friday.
Yeah.
Yeah, I think if you guys agree, yeah, that will be enough because we need to practice. It's important.
Okay, it's enough. Enough. It's okay.
Yeah, so please practice by yourself, and tomorrow again we will solve some question and then we will move to OSI model.
Okay.
I will give you but question tomorrow and you guys have to, speak your answer.
Yeah, we'll do that.
Until and unless you will not share your answer, I will not move to next topic.
Okay.
Okay?
Yes.
Okay, guys then. Bye bye.
Thank
All
you.
right. Thank
We
you.
will meet.
I have a question, Tim.
Yeah.
Do you have any information about the cyber security or no?
No, brother.
How about network security?
You can go for CCNA security, not cyber security.
No, yeah. Like, like, do you have any information about network security?
Network
Yeah.
security.
Okay, great. Okay, that's good.
Yeah, network security we have now.
Okay, great.
CCNA. Okay then.
Yeah, thank you, sir.
So I have a
Bye-bye.
question. I follow your Instagram, and
Yeah.
those questions you just posted, those are a CCNA.
Yeah.
Oh,
Those are
okay.
CCNA
Okay.
question.
Okay. All right. Thank you.
Okay.
Yeah. See you tomorrow.
Okay. Have a good day.
Thank you. Bye.
Same.